I'm gonna check on the drive space. Yep, we got plenty of space here. All right, I'm gonna turn on the mic, the wireless mic, as soon as I can find it.
Right here.
Oh, okay. Thank you. See. Okay, I think that's just about right. Not too loud, not too soft. And the recorder is on. Okay, it's recording the right channel for the audio. All right. So what I'll do is I'm going to talk about the program first, and then I'll go back and link the notes that I have at this point. Okay. So let's go ahead and get Android Studio started. Did you guys get my notes? The news item.
Yeah.
Yeah. No.
I didn't know what you were talking about though.
Yeah.
Okay, if you don't know what I'm talking about, it's probably a good thing, because if you have seen that error, then you would know what I'm talking about. It's AAPT again, that damn. I'll show you guys what I mean by that. All right, so if you have been experiencing with problems, AAPT cannot be contacted or something like that, it's because your Linux image is out of date. So the library is not compatible with what Android Studio is expecting. And for the first time, over the weekend, Android Studio itself has not been updated. Yeah, I was surprised, because I was using the virtual machine on Friday. Then I have not used it over Saturday or Sunday because I was using my own desktop, computer which has its own installation. And then back on Monday, and there had been no updates. This was like big surprise to me, because usually after a few days, like 2, it will have an update. So anyway, I got the program already up and running. So what I'll do is I'm going to run it in the virtual machine first, and then we'll see whether I have time to run it on the actual device, because it is different this time. And because I basically disassembled my whole thing. So it wants to download it now.
What program is this?
This is called Test Sensor. Or Test Sensors. Let me see what it is. Yeah, Pro. Test Sensors. It's from the same folder. You can download it and install it. I think you guys will have the latest version, because I think I uploaded the latest one. Google Drive is really nice, because if you upload multiple times to overwrite the same file, it actually tracks the multiple the multiple versions of the same file. So it's a really nice feature, because this way, if you ever need to go back to your earlier version, revision control is kind of built into it. It's not the same thing as source code revision control, but it still has a good file-based revision control. Okay, it's getting there. Finish. Probably just have to redo the whole thing, because I nuked my own installation. Yep.
If you delete the build and the app build before you zip it, it'll be so much smaller.
Oh, so it's the build that is taking up the space.
Yeah.
Yeah. So
Okay.
I deleted the build and I got down to like 2
megabytes.
Yeah.
Yeah. Okay. Gotcha. I'll write a script to do it. Yes, I know it's just a subfolder, but.
No, I didn't use it.
Gradle clean, I think is it? Gradle W clean?
Does it?
Yeah, that cleans it.
Script written.
Just have it
Because
go.
I do the clean, but Gradle immediately builds it again.
Only if you use build. If you go into the
On
command,
the command
line,
line? Oh,
and
okay.
use Gradle, I think it's Gradle W it has. And then use,
Haven't visited the command line.
yeah, if you use
Guilty.
the clean within Android Studio, it seems to rebuild it immediately. But if you go through the command line and tell it to clean, then it does it just fine.
Okay. Well, I nuked my entire setup over the weekend, so you know a lot of this stuff probably has to be set up again. Well, I suppose I can use marshmallow. Nope. Doesn't have.
Which doesn't have those in.
Doesn't have an option. I thought I got nougat already. Well, just get this up and running. And got a new Android device over the weekend too. When Amazon says your next day delivery, they're not kidding. It's like in the morning.
Yeah.
Next day in the morning when you place the order, like at night in the evening. So I ordered this Honor 8 cell phone. It's made by the same company that actually made the Nexus 6P, which is it Huawei or something like that. It's got 8 processors. It's an octa-core cell phone, and they are using I think 18 or 16 nanometer process. So the transistors are smaller, which also makes the device more. It saves power. Okay, it's doing its own thing. Who would have thought, you know, we would have octa-core cell phones? There are 8 individual cores.
You seen the
Risk versus CISC. Risk versus CISC.
Well, that's part of the equation too, but it is still impressive.
have you seen the quantum CPU stuff that Google and NASA are doing?
Nope.
They have a quantum CPU by D-Wave. It's crazy. The enclosure is like cooled to like sub-zero temperatures, and the enclosure is this gigantic metal thing. A tiny CPU at the bottom.
Sub-zero, huh?
Yeah, it has to.
Well, it depends on which zero. Are you talking about Kelvin zero or Celsius zero? It has to be Kelvin, right?
Kelvin.
It's pretty close to Kelvin zero.
Yeah, it has to be.
Has to be
so cool, because if it goes, it doesn't even take that much to go that high before it shatters. The quantum.
So when are we going to put those on cell phones? Well, I clicked the finish button a few times already. It's just taking its time to initialize. There we go. Okay, so let's see whether we can start this or not.
Kind of busy guy.
Is it test sensors zip that we're using today?
Yeah.
Download anyway.
There we go. Okay, so we got started. Very nice. And of course, the first thing I did was to start up the cell phone, hook it up to the internet, and before it even asked me to register, it spent about 45 minutes or about an hour to update itself multiple times.
It's been on the shelf for a while.
Probably not too long, because the device was launched maybe 6 months ago. It's not that old. It's not an old device. So out of the entire household, you know, we originally had 3 Nexus 5s, and this is the only one remaining. This is the first Nexus 5 of the entire house. They got dropped from 6 feet onto concrete, into the toilet, and all that stuff. You know, it's still working. And all the other devices were obsoleted in one way or another. I think my daughter killed her cell phone, and then my wife, you know, ran out of resources because she kept all the pictures on the cell phone. All right, cool. So this is working. So what I'll do is I'm going to work with this program. I'm just going to run it first, because I want to show you guys how you can actually test your program. I'm going to take out the breakpoint there. That's one little sticky issue that I have not really resolved yet. It's not like it's not working. It's just not working as efficiently as I think it could be. So it's okay. It's just not optimal at this point. And this doesn't look like nougat to me. It might be. There we go. It's gonna be up soon. There we go. All right, so this program does, two things, okay? It doesn't do very much, doesn't do a whole lot. It only does two things. And the first thing it does, okay, is it in the right point? Nope. Okay, it's just taking time to do it. All right. Still waiting. There we go. Okay. Just took a long time, and I'm not really sure why it's taking. Yeah.
Are you recording?
Yes, I believe so. Let me just check. Yep. I am recording. It's interesting because we see two of these things, which means the audio is also being fed to the virtual machine. If I use a recorder in the virtual machine right now, it will be recording the same thing, at least the audio part of the class lecture. It's kind of interesting to see that. Okay, so today's focus is working with sensors in Android. So when you press the first button, it will show you all the sensors that are available on this device. Now, this is a Nexus 5. Okay, when I ran the same program on my cell phone, the list was almost twice as long. So this is the emulator, and the emulator in this case definitely does not do the same thing or even emulate close to the devices that are on the actual device. But it's still good for debugging purposes. And then you might ask, well, how are we going to check the pressure sensor when it is a virtual machine? It's not really connected to the real world in any way. So we'll go ahead and press pressure sensor, and these three dots here expands to a separate view. So let me put this one on the one side. And you can also go to virtual sensors. Once you pull up this window, you can go to virtual sensors. And I think I just crashed it. Okay.
Dumb.
Man. Okay, it complained about.
I have the load driver.
Yeah, but that's typical. I think I set it to use software already. So let me check that. Let me check my virtual machine. Make sure it's not using. Yeah, it's using software emulation or emulated graphics. So that really should not be a problem. Show advanced settings. Emulated performance using only software. Multi-core using 2 processors, but that's experimental. So we can turn it off if it continues to cause problems. And yep, there should be no. Sorry? Yeah. There should be no big surprises here. So we'll just click finish a while back. It's just waiting for the AVD manager to accept the input. Okay, there we go. So we'll try it one more time. As the virtual machine is starting, the new computer or the new cell phone has an interesting tray for the SIM cards. So it has a tray that has 2 slots. So one slot is only for a nano SIM card, which I really do not like because I could not reuse my micro SIM card. I think there are people who can cut it out in a certain way so it will still fit the slot. But you may cut out more than the actual just packaging. When you cut into the silicon part, then it will definitely stop working. So it takes a nano SIM card, and then it also has a second slot. The second slot is dual purposed. You can put a second SIM card into it, so it's dual SIM, or you can put a micro SD card in it to expand the storage. So they're getting very clever with these things, because instead of having 2 separate slots, which will increase the expense of the device, they put it into one single tray, but then you have multiple cards on that one tray.
So you can have two phone numbers on the same phone?
Yep. Or if you go to a foreign country, you can keep your T-Mobile card while you purchase a local card, at the airport. Which is handy, it's not really required, but if you have two SIM cards, then you can simultaneously have two numbers associated with your phone, which is kind of cool. Okay, let's try one more time. Virtual send. Okay. It's crashing because of the same reason. Okay, it's lacking the driver. This is because all of these computers, or at least the way it is connected in the back, I think it's connected to the graphics card. It's connected to the video cable is connected to a expansion card instead of the slot that is right on the computer itself. So it's trying to, for some reason, when I run the, I know exactly why. There's one reason. Can't show it here because it's not loading it. There's one particular view where you can rotate and tilt the virtual device so you can shake it virtually. I think that part is what is calling for the DRI, direct draw driver, direct render driver, because it's trying to utilize the 3D rendering capability that is native to the computer. So even though the emulator itself is not doing it, this is really kind of disappointing. But that's okay.
So it's the graphic in the extended controls that's doing that?
Sorry?
You're saying it's the graphic that they use in the extended controls?
Yeah. Yep. I can see if I can install this component, R600DRI.so, and because this is one of those things where if I can get it working, it's really nice to show it. So let me check it out. It might be just a little package that I can install. Okay, so look for, it's R600 DRI.
Yeah.
Yep, .so, and we'll look for Debian. Yep, looks like a GL1-Mesa-DRI is included in the package. So let me see if I can do that. I just built this entire image over the weekend too, so it should not need a whole lot of updates. Lib GL1-Mesa-DRI. It may be installed already. Yep, it's already installed. Okay, so if it's already installed, the problem has to do with I did not remove the folder that contains the library. And I think it's somewhere in here. Nope, not in this one. There's a libc something that I need to remove for it to work. So let's see if it's here. Yep, lib std C++, it has a particular file that is reported to be out of date compared to what the system had. So I'm gonna remove this folder itself.
Because you rebuilt it back in, right?
Yeah, because I nuked the whole setup, over the weekend, and we did the whole thing, so it got reinstalled. So I'm gonna remove this, okay, and get myself out of here, and then restart the whole thing. Okay, so we start into our studio. It may or may not solve the problem. We'll give it a try. If that doesn't work, it will still be okay. I can still use my document camera so that we can look at the actual phone itself, which I think is actually a little bit more fun this time because it actually has more sensors on the actual device.
Yeah.
but it means, you know, if you're debugging your program, it might be a little bit more challenging. And I'm going to turn off the lighting. All right, so we'll give it one more try. Start with the virtual machine.
I said I bet these ones are using the onboard yeah, these ones have an additional graphics card because I'm getting a different driver.
Okay. The Intel driver knows, I know that one works for sure. It's the alternate driver that does not work.
It did the exact same thing that
Okay.
it did when I tried to do the sensors.
Uh-huh. Did it work?
But it said, yeah, no, but it said a different driver, i965 DRI instead of.
Yeah, but that could be because of the, oh, here's a ladybug. So there's my bug right there. Yeah, I'm not gonna kill it. The ladybugs are actually beneficial. They
some posters they're like eating.
they kill aphids, exactly. They are little aphid assassins. Yep.
We will call it feature.
Yep, it is a feature now. Funny. Okay, so we'll give it one more try. If it doesn't work, then I'm not gonna fudge with it. Go to virtual sensors. There we go. Okay, excellent. That works. So this is the part where, you know, why it keeps calling for the DRI driver, because it is actually 3D. You look at this and go like, nah, it's not 3D. Well, I can show you that it is. You go to move, and you see how it's, and I think, you know, it will also, you can also rotate it too. So with rotation, you can see how it's rotating. So this really helps to test the program, because now when I go back to the virtual machine, I can go to get sensors and then get one of those things where orientation matters. 3D accelerometer is one, the magnetic field sensor is the other one, so I can click on this one. And you can see how three numbers are, you know, displayed on screen. Okay, so they are reflecting, in this case, the 9 point something is basically the G-force pulling down the device. That's the y-axis. So so X goes, you know, left right, Y goes, you know, up down, and then the Z is in out. Okay, so it's basically looking, it's perpendicular to the screen itself on the device. That's the Z-axis. So when you move it around, you will see that, you know, those numbers, you know, will change as well. You can see all of these numbers changing. And then when you click on a different sensor, it will report back, you know, a different type of sensor value. You can click on humidity, okay? And then you have to go back to this screen and go to additional sensors. Then you can, you know, kind of play with the humidity or relative humidity in this case. So when you change that, you can see this value changes as well. I do not know why, you know, until you change the value, it doesn't show anything. It shows 0, 0, 0. That part, I think, is probably a bug on the part of the emulator itself. You can go to light sensor, and same thing, you know, light sensor is supposed to display 20,000 lux, and until I tweak it, it doesn't, you know, actually update the value. But the program does work, okay? All right, so after fudging with all of this stuff, yeah?
But when you try the magnetic field, though,
Yeah.
I mean, it seems like the values are odd.
Okay, this is the magnetic field. The other one was
So when you change, like when you change those values, I don't think you're getting all three of them. I don't know if it's a clue or not.
when I changed the
It's
value.
on the top right of the additionals. Top right.
Top right here.
Yeah. I was playing with that one, and I couldn't get that one to play on this one.
You are correct. It is magnetic field, and let's see, where's my...
I don't know if that was a clue to the startup or whatever.
That could be a clue, yeah.
Trying to debug it now.
Try to debug code that is not yours. I think if you adjust it here, you might have to kind of tweak it here to make the actual number change. Okay, so let's try that one more time. You know, tweak it over here, and go back to here. Nope, no, it's not changing because of that. Because I was thinking, you know, the additional sensor, this may be specifying the absolute value regardless of the orientation of the phone, so that it won't update until you rotate this.
Yeah, resulting values.
Because these values match those ones over there.
It matches the values over here,
Yeah.
but these values do not match the values over here.
Precisely.
What, if you hover over that little question mark there, does it tell you something?
It opened up a window. So in the browser, it'll open up this window here, a constant describing a magnetic field sensor type. And then you can go to sensor event.values for more details, because depending on the different types of device, the three values will be reported back different things. So when you look at accelerometer, it has one particular way of interpreting the three values, and the magnetic field has micro-Tesla as the unit, measuring the ambient magnetic field in the X, Y, and Z axes. So it's not, that was not the issue. So the issue has to do with, you know, what, it doesn't even say what these numbers are. You know, I'm assuming this is X, Y, and this is Z, but it's not described here.
What would you be able to measure with that?
With this one,
Yeah.
I do not know, but it's reported as additional sensors. So I'm not really quite sure. There's only one magnetic field sensor here, but there's also an orientation sensor, which is probably only sensing the orientation of the device, whether it's horizontal or vertical. So I clicked on the horizontal sensor, so I can go back to the accelerometer and then change the rotation of the device. The problem is, when I change the device, the orientation of the device, this will go away as well. So I have to kind of restart the whole thing. Nope, I guess not. There we go. And the screen itself is not big enough to fit everything that I wanted to fit, and I did not enable scrolling, so I lost, you know, track of all the other values. Suppose I can put it upside down. Then it will have exactly the same length. But it won't rotate upside down. In the upright position, then it will do it. But in upside down position, it doesn't seem to want to do it. Guess we can read it upside down, and then we can get orientation. It doesn't seem to change the value of the orientation. I think that's just rotation. But over here, it's not reporting any of those values changing. Getting back to the original rotation, orientation. So we can click on rotation vector sensor, and this one has actually 5 values because the indexes go from 0, 1, 2, 3, and 4 in this case. And even though this is a virtual device, I think it is emulating some kind of jitter, because you can definitely change how the rotation is making changes to those values. But when I make this device upright, it's still making some changes too. So that's kind of interesting. All right. So are there any questions about what the program does? Because this part is kind of fun because you can also click the accelerometer. Okay, so we are detecting only acceleration in this case. So when you move the device, just kind of shake it around like that, you can also see how those numbers change as a result. So it's kind of cool. You can do a lot of debugging this way already. But I'm telling you, if you hook it up to an actual device, the number of devices reported is actually different. almost twice as many in this case, because it would report uncalibrated values and also report calibrated values on an actual device. But in here, in a virtual environment, it will only give you calibrated values. There are no uncalibrated values, which makes sense because this is all virtual to begin with.
What do you mean calibrated or uncalibrated?
Sorry?
What do you mean by calibrated or uncalibrated?
I think the uncalibrated, it comes in internal units instead of actual measured units like degrees Celsius. It's basically reporting back the raw sensor reading. All right. But the key today is not to look at each individual sensor, but to look at the general schematic of, okay, how do we get to those values to begin with? And this particular sample program has two main things that it wants to illustrate. One has to do with the sensors, and the other one has to do with list views. Because when you look at the display of the software here, it has got two list views. This is a button. We know how to work with a button. This is one list view listing all the devices that are actually on the device. And this is a second list view to show the indexes of each item and also the value of each item corresponding to the device that I just clicked on. So as a result, this program is a little bit more complex than a usual program because it's trying to illustrate two things at the same time. All right, so first thing first, let's deal with sensors first. So when we deal with sensors, the initialization of the sensor in this case is in the on create event of the main activity. And the way it is done is the first thing it does is to show you, okay, what devices do we have available. And that is done by the on-click listener corresponding to the button. And all that button is going to call is populate list. Populate list is a method of main activity itself, and that contains all the logic to enumerate and print out every single device type that is available on this particular mobile device. So this is how it works. The first thing we do is we find the list view inside main activity. So this is nothing new. We know how to use the find view by ID in order to locate a particular view inside main activity or inside any other view. And I have to cast it to a list view because certain things that I'm going to do next is specific to a list view. And then the second thing that we have to do is a little bit different because this is not something that we have done before. We have to get a system sensor management, the sensor manager. The sensor manager object itself is used to handle a lot of things that you can do with sensors. And it's not just limited to managing the sensors, but it also has a lot of translation library routines that are basically static methods of sensor manager. So if you know how to do 3D transformation with matrices, those libraries of routines are actually supplied with sensor manager as well. So that makes your job a whole lot easier if you need to translate readings of 3D. If you need to translate the reading of a 3D sensor and adjust it for the way you tilt the sensor, it's just one library call away. So regardless of how you're tilting and rotating the device, you can say, okay, where's north? And it can do the conversion for you. So it's it's handy, it's very handy. But in this case, I'm not using it for that purpose. I'm getting the sensor manager object back as SM, and then the next thing I do is I'm calling SM's method called get sensor list. Now when you pass a parameter to get sensor list, you can just say, okay, I want a particular type of sensor. So if the only thing you're interested in are temperature sensors, you can just specify sensor dot type underscore, and then you can look at the options available. Okay, I think temperature is one of those. So you can get only the ones that are corresponding to what you want. But in this case, I'm specifying type underscore all because I want to look at every single sensor that is available on this mobile device. The return value is a list. Now, this is not the first time that we see a list type in this class, because we saw that, the first time we saw that is with the adapter. When we talked about MVA, we keep track of the number of listeners, and that's the first time we saw a list type. So this time we have a list of sensors, and then the next one, the next line, which is LV dot set adapter, that's a whole new concept. Okay, we haven't seen that concept before because we have not dealt with a list view before. LV is a list view because we got it initialized up here. So the adapter thing is basically the same thing that we saw with MVA. It is a connection between, in this case, a list view object, which is displaying stuff on the screen, and also what the back end, what is supplying that data to be displayed. In this case, that is a list of sensors that we know as devices. So when you look at how the variable devices is used, it is initialized here and then it's used immediately over here. Are there any questions? Yes, go ahead. Yeah, you first, and then. Yeah.
So is that sensor list adapter part, is that something you created, or is that part of the sensor manager? Sensor list adapter?
Sensor list adapter is something that I created.
Okay.
It is a nested class that is defined earlier in the class definition, so we'll get there as well.
Got it.
Question?
Yeah, the list view takes a list, basically a list object.
A list view is empty to begin with, so you have to tell it what adapter it is associated with, and then the adapter is what is going to link the content of the list view to a particular data providing object.
Okay.
So
is
in this,
that
yeah, go
providing
ahead.
object always a list or in the list?
Not necessarily. You just have to make sure that all the operations are supported. Okay. So right here, as you guys pointed out already, the magic is in the adapter itself, because the adapter is what can talk to both the list view in very specific ways. It implements certain methods of an interface, but at the same time, it also knows a list of sensors, because that's how I created the. That's how the constructor works. Is it takes a list of sensors in order to initialize its internal representation. So obviously the next thing we need to do is to look at what is a sensor list adapter, and that's pretty much at the very beginning of this whole file. So one of the first one, yep, it is the first subclass that is defined here. Not subclass, but the first embedded class. Yep.
You can control click it, it'll jump right to it.
Control click? Okay.
So when you hold down the control button, it'll highlight it, you can click it, and you'll jump right to it.
Okay, so let me do that. Control, click here, cool. So it goes right to the method, in this case the constructor. Cool, very good. I'm used to VI, so I'm even tempted to do Control F, Control B to page back and forth.
Me, it's Tico.
Sorry?
Tico.
Tico?
It's one of the first text editors.
Oh,
You'd have to be a digital guy.
I see. TCL?
Oh, no, that's a different one.
TK?
TECO?
Yep.
Yeah, it was back on tops.
Yep. Okay, so when you get to here, the constructor doesn't really do a whole lot. You pass to it a list of sensors, and it just remembers it using its private member, which is L. List is defined somewhere here. There you go. So I guess that works too, huh? Control click. Yep, there we go.
It's a nice one. It's a nice one.
Yep, it is a very handy one. There are some other control key sequences like Control Shift, and I cannot remember which one, but it will let you it would give you a lot. It would give you some options. If you remember every single hotkey in Android Studio, that's actually pretty good. But this is a really good one to remember.
That's
if,
one,
you,
yeah.
if you don't have to remember anything, this
That
is
one
a
and
good
moving forward and backwards between windows, because that'll jump to the other window and then you want to go back.
Mm-hmm.
Yeah, that's just a couple, that's just a keystroke away.
Yep. All right, so list is nothing more than a private member that remembers, okay, this adapter is associated with what. So when I construct a sensor list adapter object, it will remember what is the list of sensors that is corresponding to the adapter. So that one is pretty easy, right? It doesn't really do a single thing. And then you see a whole bunch of these public methods. Each one is a override or an implementation of an interface. When you look at the what a sensor list adapter is, it is an implementation of an interface, and the interface has a name of list adapter. And list adapter itself has a whole bunch of stuff that has to be implemented, and these are the items. I will point out some of the easier ones. Okay, is enabled. So is enabled is actually passing you a parameter, which is x. X is the row number or the item number inside the list view, and it's basically asking you, is this item enabled? Can someone click on it? Well, in this case, I have no particular reason to disable a particular sensor, so I'm always returning true. But in general, when you're dealing with a list view, you kind of have to go through the list, and then you want to determine in each case, okay, if I tell you, okay, is the fifth item enabled or not, then you kind of have to look at the data representation and determine whether that one should be enabled or not. But my default is, are all items enabled? Yes, okay? And these are all methods that are defined in the interface, so I have to implement these particular methods. Get count is an easy one because a list has a size method, so all I have to do is to return the size, the value or the return value of size from the list itself, and that becomes the count of the list view itself. In other words, it really literally is just translating things from the list view, it's translating things from the sensor list into something that is expected by the adapter. Get item is basically just saying, okay, what is the corresponding thing of position? And the way to do it is to use the built-in method in a list called get. Okay, so it's a direct translation here. Has stable IDs is basically asking the question, does each item has a stable quote-unquote ID regardless of updates? It doesn't really apply in this case, so the answer is really yes, they do have stable IDs. It's much more meaningful when you're dealing with a data set or something that is coming from a database, so that you can say, okay, if I click on the third item, if I look at the third item of a list, is it always corresponding to a particular ID, and they're talking about primary ID in that case in database terminology. But since this is not coming from a data set, the so-called ID thing doesn't really have a whole lot of meaning. Is empty is basically just a Boolean to say that to ask whether the underlying data structure is empty or not. And in this case, it just so happens that list has its own method called isEmpty, and that's exactly what is needed here. Now, if list does not have an isEmpty, you can always go to the size and compare that to 0. If the size is 0, it is empty. So that's pretty easy. Registered dataset observer and unregistered dataset observer is not used here because we are not dealing with a dataset. Get item ID, this one is not particularly useful in this case. Once again, it is useful when you're dealing with an actual database. If you're dealing with an actual database, then get item ID should be returning the primary ID of a row corresponding to position. Okay. Now, since we're not dealing with a database or data set in this case, it really does not matter. And all I'm returning in this case is returning the type ID of the sensor, which probably is not actually unique, is not guaranteed to be unique, because if there are multiple temperature sensors, then they will all report the same ID. But I'm not using ID for any actual lookup. And then we have your get view type count. Get view type count is asking you how many different kinds of type of view do you want to include in your list. In this case, there's only one, okay? Because all I want to do is to display the name of a particular sensor. But if you want to display, in some cases you want to display just the name, and in some cases you want to display the picture, then you will have two different types of views. But in this case, I only have one type of view, so I've just returned the one here. And as a result of that, get item view type is always returning a 0 because the value is 0 oriented. If you only have one type of view, then every single view must, subview inside the list view has to be of the type 0. Now, how you want to enumerate, if you have multiple view types, the way you enumerate the view types is entirely up to you. But you will have to have some kind of logic to deal with that. Can anyone kind of imagine why they have something like this? They want to register, how many kind of views do you have, and then for each row, for each item in the list view, it will ask you, oh, what about this one? What kind of view is that? And it's entirely up to your code to determine, oh, anything that displays an icon is 0, anything that displays text is 1, and so on. That's entirely up to you to decide. Why do you think it has a function call like that? What would be one of the cases where this may be useful? It's for reusing views. So when you're redrawing something, when you're updating the data set, it would use this to basically say, oh, the new thing is supposed to be the same as the other one, so it would try to reuse a view so that you don't have to recreate the views every single time. Okay? So this is kind of handy for optimization. All right, so, but nothing here is actually displaying anything. The only thing that is going to display something is get view over here. So this is actually the core of the logic inside a list view. The other ones are really just supporting this particular function. So in this case, it has get view is supposed to return a view, and whatever it returns is going to become a component, an item, an element inside the list view construct itself. Is that okay? So this call is basically, this method is being called from a list view and say, okay, I'm working on the third item. What is it supposed to look like? Tell me. And then whatever you return becomes the item 3 inside the list view object. Okay? So that's why you're given 3 parameters. The first parameter is kind of self-explanatory because all it's basically saying is, okay, we're dealing with position 0, position 1, position 2, position 3. So now you have to look at your data set or whatever is representing the data behind the list view and say, okay, we're dealing with the third one, and what is it supposed to be? The second parameter, v, is for reusing. In other words, a list view is smart enough to look at the type of a particular view and say, can we reuse a particular view? If it can, it will give you something that is non-null. On the other hand, if it cannot, then it will give you a null value for the second parameter, in which case you will have to initialize and create that particular object. The third parameter tells you the parent of a particular view or where it is supposed to go to. Most of the time, you don't really need to use that. All right, so in here, we have some kind of strange logic here. The first one is to ask, is v null? Because if v is null, then we don't have a choice but to create a new view for that. On the other hand, if v is not null, but it is not an instance of text view, then we have to create a text view as well. Because I need a text view for this particular view, So I need to do something like that. And then once we get the text view, then we can go ahead and set the text. And the content of the text depends on position, because the position of the item in list view is corresponding to the position in the list of sensors itself. So by using list.get, I'm getting the item back from the list at position, which is going to be a sensor. Now because that one is a sensor, I can now get the name of the sensor, and then we can set the text of the text view to that particular name. The second line is only only here to set the color of the text, so it's really of no major consequence. Once everything is done, I return V itself back to the caller, who is really just trying to populate the individual items inside the list view. Are there any questions about this particular method? Because this really is the key, the core of an adapter. It is just linking whatever is the data behind a list view and say, okay, how do we massage that data and display something on screen using a view? Any questions about this part? Yep.
So you're taking all sorts of types of view into it, and then cast it into a text view so you can change the name.
That is, well, V itself is a view. So when you say new text view over here, it guarantees that this is the result of this particular new is going to be a text view, but you can always assign a text view to a view because you are upcasting it. You cannot downcast it easily. So downcasting requires specific typecasting, but upcasting is automatic.
When you're using text view in front of V, when you say the color.
Correct, because at that time, V is no longer, because the type of V itself is always just a general view, which is the superclass.
Okay.
So you have to downcast it to a text view first before you can use set text.
Okay.
So that's why we kind of nest the type casting with only V, but then after we have a reference to a text view, then we can make use of methods that are specific to text views. Okay, all right, very good. So this part populates. Is that good?
Yeah, I was looking in parentheses, yeah.
Okay. All right. So this is how we get the text view itself to populate. And let me run the program again and show you which code is, or what is the action corresponding to this code. So when you, okay, run it again. It's not restarting it. I guess I can stop it first and then restart it. There we go. So when I click this button, this is the result of calling this particular method many, many times. So for each item, for each sensor on the list, it is this subroutine, this method is called once for each item in the list. Is that okay? Yep.
And
Go
that was
ahead.
done down at the bottom, right? When you made the list.
Yeah, that one is next. That one is next.
Okay.
Yep. So now the question is, okay, how do we respond to a click on these items? Just because I can show the items doesn't mean that it will respond to clicks. So now we want to take a look at the code that will associate a click on a particular item inside the list view to a listener. For that part, we can scroll back down to onCreate, okay, because I did not really make this program really modular, but in onCreate we have, okay, let me hide this part a little bit more so we can show more code. So you can see this line here. It is setting up the on item click listener, okay, and this belongs to a list view because you can see how I cast the view into a list view first. So this will find me a general view, but I have to cast that general view into a list view first because only a list view has this particular method called set on item click listener, which is basically letting you to specify, okay, if somebody is clicking on a particular item inside the list view, how do we deal with that? Okay, that's basically answering that question. Okay, so expanding this code, we can see the actual details. So on item click is the only method, well, yeah, this is the only method you have to implement in a on item click listener, which is an interface. It is given these parameters. L is the ID, I is the position of the item, and then view is the view corresponding to what is being clicked on, and then adapter view is the parent, which in this case is our list view. So it's giving you all of these particular items just in case you need one or more of these items. In this case, I would go back to the sensor list adapter, and I'm just casting it first because the adapter is already here. But when you call adapter view, which is the list view itself, and you're calling the get adapter method, it will just get you back in the general adapter. But we know that we have a subclass of an adapter known as a sensor list adapter, which is listed up there. And then it will, and then what we do is we get the specific sensor that we are interested in using SLA.getItem. And if just to make sure it is non-null, okay, if it is null, if it is non-null, we have to unregister the previous listener because we don't want to keep listeners around unless they're needed because they would just chew up time. So if we already have a listener associated with a particular sensor, we unregister that first. So that one is now gone. And then we'll re-register another sensor event listener, which is kind of analogous to the on-click listener type of thing. It allows you to specify an action of, okay, so what do we do when somebody, when an event happens with a sensor? There are two methods you have to implement. I do not do a single thing about on accuracy changed. In other words, when the sensor's accuracy is changing, I'm not doing anything about it. Okay, I'm just going like, whatever. On the other hand, if the value of a particular sensor changes, which is corresponding to the on sensor changed event, I want to do something about it. I want to update whatever is displayed on the screen. This is the second list on the screen itself. Is that okay? And this is the part that took me a lot of time. I could not optimize this to the point where I do not need to recreate a new adapter every single time. So when you look at this code, it does work. It's just that it doesn't work very efficiently. And this is not the only part that is not efficient. There's an earlier part that is not efficient. This is actually okay. So when the value of a sensor changes, then the first thing I check is whether the value array adapter, which is kind of the same thing as a sensor list adapter, except this one deals with a value index value pair. So I would have this object. If it is already, if it's still null, I will create a new one. If it is not null, I will just reuse it. And the way I reuse it is to set the values. In other words, the values is a part of sensor event. Sensor event is the only parameter being specified on the on sensor changed method. In other words, when you get an event of on sensor changed, then the system will pass you a sensor event, which is an object, and in this particular object includes the values, the current values corresponding to whatever sensor that is causing this to happen. Is that okay? And I would set the values, of my VAA, which is a value array adapter, to the new values. And then the next thing I need to do, this is only internal. This is changing the adapter itself, but it doesn't update the screen. In order to update the screen, I would need to do something like this. I would have to invalidate all the views inside that particular list view. This is the second list view corresponding to the values of the sensors. Is that okay so far or not? Okay, so far okay? All right. So what happens is when you invalidate all the views, or this is the first time you set the adapter, either one will trigger a whole bunch of operations. So either you are setting the adapter of a particular list view, or you're saying invalidate views for a list view. It's going to reiterate and go through every single item in the list view and ask, oh, what is supposed to go here? What is supposed to go here? What is supposed to go here? And so on. So now we have to refer back to a value array adapter to see the actual logic corresponding to that action. And this one is a little bit more complicated too. Let's see if that works. And we'll do control click. Okay, that works. It jumps to the constructor instead of the class definition, but that's
Yeah,
correct.
it moves you around.
But
The other little green arrows too on the side will take you up to the parent declaration.
Yeah, these
declaration.
can be confusing if it's the first time you do it, because it navigates to a file that is corresponding to, in this case, in a list adapter.
Correct.
Yep.
So you can find out where they're declared, and that's where you find the documentation.
Yep. So anyway, getting back to the value array adapter, this one is extending a base class called base adapter so that I don't have to supply everything, and it also has one particular method that is really handy. But it extends a base adapter, implements a list adapter, which is kind of similar to the one before. It has a private member. I should have used it in private here because nobody else really needs to know this. But it has a values member, and the values member is updated by the constructor itself. There's only one constructor, and the only constructor has a parameter of v, which is an array of floats. So whenever it is created, I will specify values as a member to be whatever the parameter v is here, so that I can internally, the adapter can track the data. Set values is doing pretty much the same thing, but without have to be called from the constructor. In other words, to make this code more modular, I should have called set values inside the constructor instead of doing this separately. And then we have a whole bunch of things that we have already talked about. All items enabled, yes. Is enabled, return true. But in this case, actually I can say, all items enabled, I can return a false, because clicking on the values of a particular sensor doesn't do a single thing. Now, when it's enabled, it simply means that if I want to associate a on item click listener, I can do so. But since I don't have one associated, it doesn't do a single thing. Okay. Same thing with is enabled I. This is just asking for item I is enabled. Yes. I do not have anything to do for registering dataset observer or unregistering dataset. Get count is in this case returning values.length. The reason why this is not size in parentheses with parentheses anymore is because values is an array. It's a built-in type array. It is not an object. So values.length is retrieving the properties of an array, which is basically the same thing as number of items in the array. Is that okay so far? So it's doing the same thing as .size in the case of a list, but in this case it's an array, and that's why I use .length instead. Get item I is returning the item at index I of values. Okay, so no big deal here. Get item ID, once again, is just returning a unique ID that is supposed to be unique to an item. And in this case, I'm just returning I itself. Okay, in other words, the position of the item in the array is its own ID. I don't really have anything else to specify as the ID. So this is just as good as anything else. Is that okay? Because we're not dealing with a database, so there's no primary ID associated with each item. And in the lack of that, you can just specify the row number. It's just as good. You cannot not implement this because this is required by the interface. Has stable IDs. I'm just returning true because I cannot really change those things behind the scene anyway. So once again, the key is here, which is get view. And this is where I'm kind of sticking. It's not working the way I want it to work. It is working, just not the way I want it. Okay. So I will show you what I have at this point. Value view and index view are just general views here. and you can see how they're initialized. One is retrieving value item as a component inside that particular view, and one is retrieving index item in that particular view. This is also a good time to point out that value index, or the view that goes into this window, has its own layout. It has its own layout, and if I zoom in close enough, you can see the layout itself. So this means you can actually create any layout you want and use it to specify. Okay, this part doesn't really matter, that's just the title of the app itself. But the layout itself, when you click on the layout, it just consists of a particular text view here, another text view over here. And it's a linear layout, but arranged horizontally instead of vertically. Is that part okay? This is just a layout. I'm not using this layout for an activity. This is just a layout. I'm using it for a particular item inside a list view. Because when you specify a layout, you're not really locking it to a particular activity or how you want to use it. Any view can be inflated from a layout. Because what a layout is, okay, when you look at the actual implementation or the representation of a layout, this is what it is. Okay, a layout is nothing more than a container inside, specified as an XML file that says, okay, we have these components, this component is over here, this one is over here, and so on. Now, what I could not get it to work is to recognize that this particular layout has a particular class associated with it. So I was not able to make it instantiate only objects of this subclass. And I'll show you why, what the code was doing instead of doing this. So this is the subclass that I have specified that is supposed to go with this, but it never really got that. That's the part that I could not get working. So in here, remember the second parameter view over here is an attempt to reuse a view when there's no need to create a new one. In this case, there are tons of reasons why you just reuse an old one, because it's the same thing. I'm just changing the values. So when we get to this conditional statement, the first thing I check is that null? In other words, do I have to create a new view for this item inside this view? If view is no, then we'll go ahead and inflate that particular view from the layout from scratch. So this view is actually created from scratch because of the inflation. Li is known as a layout inflator. It is created when we get into the onCreate method of main activity. So that's not the most important part. It's just an object that can be used to inflate a layout. And then when we call the inflate method, the first thing we specify is really an integer that specifies the layout itself. It's no different from r.id.something, except it's not an ID. This integer actually identifies a particular layout, and the value of the integer depends on how the compiler compiles the XML file, so it only has to be internally consistent. We don't actually need to know the exact integer value. This null is actually important. This null is basically saying, okay, we're inflating a particular view, who is containing it? And instead of specifying who is containing it, which is quote-unquote view group, we just leave it as null. Okay, because if you inflate it inside view group, it will actually not work. It will give you a runtime exception, because you're not supposed to inflate something inside a container when you're inside a list adapter object. Trust me, I tried that. It came back with a runtime exception. Okay, now this is the part that I could not get working. View is a superclass, and in this case, index value view is a subclass. So I'm just asking, okay, if we're reusing a particular view, is it already the kind that I want? Because if it's already the kind that I want, then I don't want to have to reinflate it and recreate the whole thing. That takes a bit of time. So I'm trying to save, all the time from re-inflating something unnecessarily. And as it turns out, every single time, it is not an instance of the subclass because it would never really invoke the subclass constructor. In other words, what I could not get it to work is to have the inflate to actually inflate the layout so that it returns something of a subclass instead of the superclass. I just could not get that to work. So I was still working on it this morning, trying out different ways to get it to work, but it's not working. This code is now, it is functional, but it is not optimized. Every single time it is going to re-inflate, which is time consuming. But once it does have everything inflated, then I will have value view as the first item, which is the left-hand side text view, and then index view is the right-hand side portion, and then the first one is set to the index and a colon and a space, and then the second item is set to the actual value, which is a float value. And that set up the entire view, and that's why in the simulator, when I click on one of these things, when I click on a 3-axis accelerometer, you will see 3 lines here, and each line looks like a number, which is the index number, colon, the space, and then a floating point number that is actually the value corresponding to that portion of the value. Is that okay? Sort of. So, as I said, I have one thing that I was really hoping that I would be able to do, which is to reuse the views, and I could not get that to work. Now, how do I know that that part is not working, right? Because, what if it's working already and you just don't know about it? Well, the way I can know about that one is to put a breakpoint here, okay? So let's put a breakpoint here, and then this time we'll run the program again, but with debugger.
It causes mine to crash every time when I break.
What?
It's complaining when I try my breakpoints when I just clear my window. That it's in the wrong thread.
This thing does not create new threads. That is weird.
Dr. Tack?
Yeah.
Would you mind turning on line numbers on your
Absolutely. Go to view line numbers.
I think you can right click on the bar where they would be. Right click on
Yeah.
Here?
Right there. Right click.
Show line numbers. There we go. Cool.
Thank you.
Mm-hmm.
It says the current thread is not the get debug thread.
Are you putting a breakpoint on line 29 or something like that?
Mm-hmm.
Okay.
136.
136. Well, we're still in the same thread.
Yeah, this is a different implementation than what you have up there.
Different implementation.
Yeah, because your line when you say is view equals null, and then you try to assign where the value view is equal to the find value item, or the index view is equal to the index item is equal to null. Then you do all this. Yours you just have the view instance of. So line
Okay.
numbers they're different files.
Okay.
You got the latest.
I may not have updated the one on, but it wouldn't change the threading structure though. Because
Yeah, it shouldn't. It's just whenever I set the breakpoint, it went close. I ran the app right away.
Mm-hmm.
Then I threw a breakpoint. I'm cleaning it up.
All right. Well, it says disconnected from target VM. Okay, let's do it again. There we go. Okay. So it won't do a single. Well, it just crashed again. The virtual machine crashed. Disconnected from target VM, and the virtual machine just stopped working.
And it's still there.
Okay, let's start one more time. connected devices, okay.
Maybe it needs to be completely turned off and restarted, the virtual machine.
Possibly.
Yeah.
Okay, so fatal exception, the system died. Earlier logs will point to the root course. Okay, so, oh, there's nothing here that will indicate that. Okay, let me see if I can get my phone to work too. Then we can just use a document camera to look at it. All right.
I can run the app, I can't debug it.
All right, so let's see if this works. So I'm gonna turn this off entirely because the virtual machine seems to have some problems. So this time we'll run it again, but this time we'll hook it up to my actual Nexus 5. Yes, my Nexus 5 is running the Nougat. Almost the latest one. The latest one is 7.1.12, I think, from 0.2, and I'm running just one minor revision away from the latest one, which is not always a good thing.
Tried plugging an actual phone into it yet?
Sorry?
I said I haven't tried doing that, plugging an actual phone into it yet.
Oh, it won't explode.
Your mileage may vary.
The mileage may vary, yes. Okay, so let me see if I can display this. Okay. I have to do a whole bunch of things to make it show well because I always turn my screen all the way down to save battery, but to handle all the background lighting, it really helps to kind of crank it up. All right. So let's go back to the program and look at the document camera. Where's that? Oh, right here. There we go. All right. So I click on get sensors, and it gets all the different sensors, and I just have to. And you can also see how these sensors are different from what we saw from the virtual machine. You can see how many there are. So we have just a little more than an entire screen with or the list view itself would fit on the screen. So I'll pick on one. We'll pick on magnetometer. And at this point, it goes into the breakpoint, which is okay. It should get into this breakpoint 3 times, exactly 3 times, because that will correspond to each value in the thing. But you can see how it is getting into here every single time. And the way I know that it is not an instance of index value view is because view already has a value. It already has a value, but it's not registering as an instance of index value view. Instead, it is just a linear layout. Now, I understand why it is a linear layout, but it also should be.
Why'd you try casting it when you assigned it?
It probably won't cast. It cannot cast it because it's not an instance of that. It cannot cast it to something it's not an instance of. This is already the as low as it goes in the subclass hierarchy. But I think I might have a reason. I might know why it is not working. Because in my index view, Java, it's extending view, and instead of extending linear layout. Maybe if I change it to extending linear layout, it will work. But it's not complaining, which is the other problem. Is it's not complaining. Oh, okay, just timed out here. Okay, let's go back. All right. So you can also see how. Oh, maybe not.
It's still debugging.
Yeah, yep, that's fine. Okay. Let's go back to debugger, and we'll just take out this breakpoint. This is the other breakpoint that we never got to. This is a breakpoint inside the constructor of index value view, and since we never stop here, it means it never used this constructor. This class was never used at all. And one of the potential reasons is I'm extending the wrong superclass. I should be extending linear layout as my superclass instead of just a general view. That might be the reason too. But let me go back to the other breakpoint so the program can continue to work.
Yeah, I can't look.
Okay. So now the program is working, and you can see how the values are changing rather rapidly. Oh, okay. It's hard to keep the contrast at the right level. But you can probably see the values updating, changing, and depending on how I change the orientation, and depending on, okay, let's see, we click on magnetometer, and that changes a lot slowly, more slowly. It's like every second or so. That's the magnetometer. All right. Any questions about this part? No questions? All right, so we'll give it one try, okay? So what I'll do is I'm gonna change the subclass here. So I'm gonna do a linear layout as my superclass, and then rerun the whole program and see whether it will stop at this breakpoint. Okay, go back to the document camera. Okay, so click that, and then you click one of the sensors. Nope, it does not. It doesn't trigger the breakpoint, so I'm still not getting a subclass instantiated. I'm only getting the superclass instantiated, and the superclass is specified by this thing here. It is a linear layout, but there's no way for me to associate a whatever I'm defining here to a particular subclass. This line doesn't work. So that's where I'm kind of stuck at this point, is how do I associate a subclass with a layout. Now there's another thing you can do, is to do the view itself has a static method called inflate. You can do an inflation from there. But that inflation is not going to work because it always wants to attach whatever you're inflating with, what you're inflating to a root, to a bigger window, to a container. So that one does not work. So I'm still doing some research right now because that's the only sure way to say, okay, this is the kind of view that I want. Okay, here's the next question. Is that code really needed? In other words, do I really need to use a subclass here in order to say, okay, is this the class that we want or not? So let's say we take this out, okay? We can take this out entirely and just say that if we are past a view that is null, then we'll go ahead and inflate it from scratch. Otherwise, we'll reuse it. We'll just make the assumption that it does work, okay? So we'll go ahead and test this code again without checking whether it is of the proper layout, okay? My guess is it should work. The reason why it should work is because I already told in the adapter, I already told the list view that there's only one type of view, right? So if there's only one type of view, then you can reuse the view anytime, for any number of iterations that is necessary. Is that making any sense? Okay. So we'll go ahead and test whether this code works or not, and we'll put a breakpoint back here because we should only see this being called a few times, like 3 times, if there are only 3 values to update. And then we'll put it in debug mode. And it's restarting the app. There we go. Oh, you guys cannot see it. There we go. So get sensors, and we'll pick something that only has like 3 values. The accelerometer only has 3 values. There we go. So we'll count. 1, 2, 3. That's it. So at this point, when you switch back here, you can still see the number being changing really rapidly, but it's reusing those views now. So I only needed to inflate 3 times because each one is its own view and it needs the inflation. But after I got all the inflations, it's reusing those views, which is a lot more efficient than having to re-inflate every single time. So even though I cannot confirm using the subclass or using an instance of, which would be ideal, but I can kind of use that particular thing, which is specifying the number of types of views and also returning what is the type of view for each particular item. And using that, I can actually get the same result to make sure that it is a compatible view. Is that okay so far? So the adapter has internal logic to try to reuse the same type of display as much as it can, but it requires my own logic to specify, oh, this is the type of this particular elemental view, this is the type of this particular elemental view, and then this view will try its best to reuse, the adapter will try its best to reuse the views as much as it can, which is, in this case, it's more efficient. All right, are there any questions about this particular program? Now the sensor manager actually is really useful. I just want to bring that up before we end today's lecture. So when you go to sensor manager, there we go. It contains a lot of methods for translating coordinates and directions. So when you look into the subroutines, it's methods. Okay, that's got to be a faster way to get to the methods. Or not. It has a whole bunch of subroutines or methods for just translating the coordinates. And it also has these calls, so if you really just need to know the altitude at this point or the angle change, you can just call these methods. Help a function to compute angle change between 2 rotation matrices. So that's really handy because you can just give it 2 matrices and it can figure out the distance or the angle change. And there's a whole bunch of static methods. Get orientation computes the device's orientation based on the rotation matrix. So it can do the conversion for you. And this one computes inclination as well as rotation matrices, transforming a vector from the device coordinate system to the world's coordinate system, which is defined as a direction orthonormal basis. And this is really handy if you want to know where to expect the sun at a particular time of the day. So there's a whole bunch of stuff you can do with Sensor Manager. In addition to managing the actual sensors, it supplies a whole bunch of methods for doing all the math for you. Okay. Any questions about this part? Nobody has any questions? Cool. Okay. So I will continue to look into that thing of trying to create a subclass of a view from inflating it, but that's just my obsession for the past day or so. And I'm going to link I'm still logged in as myself, because I was asked to look into somebody's profile to see if that person was doing any work in a psychology class. And what we'll do is we go to sensors, and we'll go ahead and link in the notes, because I wrote some notes already. It's just not entirely done, so but it will still be good to include those. So URL. And I actually remember the entire URL. http ludolosrios.edu. My name, teachers, ARs, modules, and this is 6.8. And then the other one has to do with lists. That one is not done yet. This one is done. The other one is sort of done, but I was kind of stuck at the point where I want to know how to reuse a particular view. So that one is not entirely done yet, but I can put a link here at least. Introduction to list view. Okay, and it's good to double check, make sure, yep. And we'll make sure of the other one too, yep, there we go. So we got the notes linked in, and then the zip file is already online, but it's not the same as what I had.
I don't know about that one, I pulled the one out of the Dropbox.
The Dropbox.
That one was different, it was much smaller when I clicked on it.
Are you picking the one from the share drive
I grabbed the one from the shared drive the first time.
today?
Yeah.
Okay.
And this one here doesn't have the builds. So it's much smaller.
It does not have the builds. So you're talking about this particular test sensor?
Yeah, that one was big.
Yeah.
Then you had another one in the notes. I
In the
clicked and it
notes.
said another download of test sensors, that's it.
And that one is smaller?
On Moodle?
Yeah.
Yeah, that one downloaded in a click.
That is strange.
It was 1.5 meg big.
That is interesting. Because I don't usually clean up my build. Okay, if I say clean project, does it clean and build at the same time or just clean?
It cleans and builds.
Yeah,
Cleans
you
and
have
Almost so
to-
fast you can't beat it.
You have to do it from the terminal.
Okay, okay, so let's try to do it from the terminal. So we'll get out of Inver Studio altogether. Go to a terminal. Go to test sensor as a folder. Go to
No, you got it right there. Go to /Gradle W.
go to
Type /Gradle W
dot
/ and then Gradle W
oh
Fire-
okay.
fire the script.
and
Gotcha.
then clean. And all it does is clean it. Doesn't do
okay.
It's like it's doing a lot more than that.
It has to download a whole bunch of resources the first time to actually do everything. It's stupid.
That's a whole lot of Trojans.
Potentially, yes. And whoever needs to update your Debian image, we can do it today. We can do it today, just after this is all done. Okay, so let's check, how much space it's using. EU max depth equals 0-h here. 6 megabytes. Better. It was
Yes.
30.
I just went there and tapped out the builds and deleted them.
Well, let's
I
see
got
what
down to pretty close to that.
Okay, let's see what build has at this point. Nope, it doesn't have a build folder anymore. It has Gradle, it has app, so I would imagine most of it is in app now. No, app doesn't have a whole lot. 240, oh, I need a -h, there we go. So app doesn't really have that much, it only has 240 kilobytes. So maybe we can change this to 1 and see who's taking up all the, nope, there's nothing there. So whatever is taking up all the space is here. Nope. Why is it taking up 6 megabytes when they don't add up?
It's in the Gradle directory.
So app doesn't take up that much space. Oh, I'm still asking for app. There we go. 6 megabytes. Yeah, Gradle itself is taking up 6 megabytes.
Okay, yeah.
So those are the tools that I just pulled in.
Yeah.
Okay.
But you saved like 50 something megabytes by doing that.
I just went into the file manager and just deleted the builds. And I
Right,
didn't
because-
add all this other stuff. I just tapped them away and then
Mhm.
re-imported the project. It built just fine.
Okay.
I'm like, instead of sending you the binaries.
Which I'm gonna rebuild anyway.
Which you're gonna rebuild anyway.
Right. Yep, that makes sense. All right. Well, so I'm gonna end today's lecture. There's no outstanding homework assignment because I think the other one was due today, right?
Yep.
So what's the next
Yep.
one?
The next one is the next class I will talk about GPS because those are the requests from last time. Not really quite sure what to use as a homework assignment because it's all of these programs are standalone individual programs to illustrate one aspect of using Android. So what I want you guys to do really is to think of a project that you really want to do and then just kind of work your way toward that goal.
Boil the ocean, is that too big?
Sorry?
Boil the ocean, is that too big?
Boil the ocean. Well, you have to melt the ice cap too. we just spotted how many other rocky planets over the weekend.
Yeah, we got 7 in other systems that are all in the habitable zone.
Yeah, and they are
40
only within
light years away.
Yeah, only a few light years. No big deal. We can do it.
I can send some DNA. I'm sure I'll be around then.
Yeah, I think it's a political joke, but I'm not gonna, lean one way or another. But Bill Myers, said something about, that too, that we are discovering, foreign planets, or rocky planets that are far away, and he said NASA is probably having a conspiracy to invite an invasion from an alien species, just so that we can take them to the leader.
Take me to your leader.
Take me to the leader. Yes, we'll go. We'll
He'll
point
shake
you
your
the right
hand
way.
for like 30 seconds.
But that was kind of funny.
If he really wants to keep aliens, how does he need to build a wall of Max? So he needs to build it in space.
Well, the thing about alien invasion is it doesn't really make a lot of sense because any alien species that can cross over that kind of span of outer space would have no value, on Earth. I mean, the Earth, maybe they will helium is worth a lot more than what we have on the planet because helium can be used for fusion and stuff like that. They're not going to look for humans for food. Okay, we are not really the best. We don't have the best energy content.
You make good slaves too.
No, we're too lazy.
No, but if they can cross, that kind of span of space, they're not going to be life forms like we are. Okay, because
we probably crossed from space. We're deposited on this planet, and if you look at the spheres, our spaceships are like really down in the Indian Ocean. So you have to lose an entire airplane to pull it up. We probably came here on a spaceship ourselves. You don't think we evolved like this, do you seriously? We are so far advanced of all other familiar farms.
but they can just they can put the machine here and then and then manufacture whatever they need to instead of actually transporting us. The biggest problem about outer space transportation is outer space, the radiation of outer space, because that's just going to corrupt any type of DNA sample. So whatever you want to plant on the planet, you probably just want to carry the information to do it in some really kind of indestructible form. And then you construct a machine on the surface of the planet with the protection away from all the cosmic radiation. Then you have a pretty good chance of actually manufacturing it.
I don't know, I bet you they spent a lot of ships to a lot of different places. Once we got here, we couldn't maintain our technology. We couldn't do anything, so we named everything we could eat. Right? We figured out how to prepare it, and we passed that along.
I think I buy the Guyver storyline a little bit better. they came here and then they were looking for a slave species. They look at the natives and go like, yeah, they show some promise as slaves, and then they converted all the humans to become their warriors. But then humans became too good of a warrior, and then they had to leave because just look up that Japanese manga called Guyver, Guyver. If you do not like violence or anything like that, don't read it, don't watch it. Yeah. But it has a pretty good storyline as a science fiction. Alrighty, I'm gonna close the recorder.